Greetings, I'm Shad and I'm here at St. Patrick's Cathedral in Melbourne, Victoria, Australia. Now, in Australia, we don't have any real castles, but we do have some excellent examples of classic Gothic style architecture. And that is not too far removed from medieval style architecture. And I'm taking this opportunity to share with you what the main defining principles of Gothic style architecture are and what kind of advancements, what differences there were in castle architecture compared to Gothic architecture, what changed and what enabled us to build buildings like this, which are just mind-bogglingly beautiful. It is amazing. So please have a very close look at the shots we're going to be taking while we go around and look at these specific architectural principles of Gothic architecture. Now, to begin with, one of the key differences between castle and Gothic style architecture is the thickness of the walls. Now, first you might be thinking, well, that's kind of obvious because in a castle it's a defensive structure, therefore you would want thick walls. That is true, but it was also an architectural limitation. They didn't know how to build high with stone by making it thin. By making it thicker, that added more support and stability in the wall as it was going up. And so what they discovered, the key kind of design principle that enabled them to thin the walls in stone structures and build them as high was what we see behind me. Now what you'll see on here are little kind of half walls that are extending out of the cathedral. These are called buttresses. Now a buttress adds it adds stability to the wall. Now, in comparison to, say, a castle wall that was as thick as the buttresses are extending, well, this cathedral wall is actually as stable because of those buttresses as a castle wall if it was as thick as far as the buttresses were extending. And so by adding those buttresses, you keep the stability of what a thick castle wall would have been giving, all right? But it enables the wall to be much, much thinner. Now, with thinner walls, all right, that actually adds a lot of advantages in design. For one, it's a lot easier to add windows, and you can build them with less materials. But when we come to windows, these windows that we're seeing here are not only incredibly beautiful windows, okay, they are also there for architectural reasons as well. Look at this beautiful, gorgeous, massive, feature window in front of the cathedral. Imagine if that was just stone, okay? And then try and figure out how much weight would be there if that was just straight, sheer stone wall. We'd be at least talking tons, a ton or more or something like that. But by adding this beautiful, huge window, we have removed heaps of weight from the wall, okay? Now what that does, that would weaken it, generally, unless you make the window a certain way. And what you see here is an arch. And it's not just an arch window. It is an arch window that is divided into smaller arches and then again, smaller arches again, okay? And by doing that, that distributes the load from on top of the window to the sides perfectly while keeping almost as much structural strength if it was all stone, but the advantage is it's so much lighter. And so because there is so much less weight pressing down on the wall, it actually ends up being far stronger in the trade. What I'm talking about here is the trade-off between the strength that you get in comparison to the weight. And so now the wall is so much lighter because you removed all this mass from it and put this beautiful window in, which puts less stress on the buttresses that are holding it up and everything else. And so it's funny how when you do something like this for an architectural reason, it also opens up what are just such classically beautiful architectural designs, especially the arches, because the arches are there purely for architecture, okay, but it creates such an incredibly beautiful building, like a window. And this huge feature window is just incredible, okay? But take a close look at that, okay? Because I want you to really have a look at it and see how the load is being distributed from that window with all the smaller arches and smaller arches within it. It's just ingenious, okay? It is absolute ingenious architectural design what we see here, and it just looks amazing as well. Now, in relation to the buttresses, have a look at what is happening right here. You'll see at the top of the buttress is very thin and close to the main structure, okay? But as we go down, it's creeping out, extending bit by bit, further and further out as we go down on the cathedral. Now what that is, it's distributing load, okay? For one, the load of the buttress itself will be forced to lean inwards towards the cathedral, but also when there's any stress from wind and other things like that, that causes the buttress to be, that causes the cathedral to be pushed out a bit. And so in this case, if there's a bit more stress and pressure pushing the this tower here a bit to our right, all right, it's going to be, that load is going to be angled down all the way to the base of the buttress here. And so there's a very, very specific reason as to why these buttresses are on an angle like we see here. So this is the side of the cathedral, and it really demonstrates what I was saying here about what the buttresses are doing. You see each buttress in line behind me, all right? Now imagine if that was actually all the space in between those buttresses. Imagine if that was all stone, and this wall would have been what? It would be about 2 meters thick to support the height that what we're seeing here. Well, traditionally, that's what a castle wall would have been like, okay? Because you need, the extension to support the higher weight, and what we see here. But with the ingenious design of the buttresses, all right, you can remove most of the weight, and the wall ends up being as strong as if it was as thick as the furthest extending buttress. All right, there is another design element that I really want to point out, and what it is called a flying buttress. So it's a bit different to these buttresses that we see here. It's called a flying buttress. Now it's hard to see, I'm going to zoom in and it might get a bit shaky, but do you see that bit of extension there, that stone extension? It's going out from the inner wall to the outer wall. That is what is called a flying buttress. So with cathedrals like this, okay, they are very, very open and very, very high. And what we'll see is that they're all kind of in an arch formation, especially the central part. Now what that creates is, the arch distributes the load onto the sides, but then it pushes it out sideways, all right? Oh, beautiful, we've got such a better shot of this flying buttress right there, okay? And so from the roof is tipped, okay? And then that load is going to be pushing out left and right on the sides of this central body of the cathedral. So to counter that, this is where the flying buttress is put in, okay? By putting that there, that puts a counter force that presses inwards on the load that is being pressed outwards from the tip of the roof, and because that counter pressure is there, that then redistributes the load down, all the way down to the foundation. And what we see on the left side of this flying buttress is again another buttress. Look at that, but it's not a flying one, it's a regular buttress. Well, actually, no, there is a specific name for it. I'll look it up and put it in writing on the screen. What we see here, because this buttress here is angled, like we see before, see how it's thinner at the top, and then it gets bigger and bigger and bigger as it goes down, okay? That makes this load lean in a bit, but then it's pressing up against the flying buttress here, which then presses it in, and it balances. It all balances perfectly, and then all that load gets pushed down. The next thing that I want to point out is the contrast in the shade of stone, okay? And so most of the cathedral is all dark black stone, but the mortar in between them is of a lighter colour, and then what we have is the feature stone. And so the stones around all the windows and the door frames and the other parts of the cathedral, what we have is of a brighter colour. And that creates such just an eye-popping contrast. And you want that because some of the most beautiful parts of this cathedral are the windows specifically. And so by making it a brighter colour, a different contrasting shade of stone, it draws the attention of the eye towards the really beautiful parts. And it just looks amazing. So what is not completely obvious about cathedral designs, and St. Patrick's Cathedral really is very indicative of classic Gothic cathedral design, and I'll mention why that is in just a second, but what you might not notice is that the design is deceptively simple, okay? You can break down the major parts of the designs into fairly basic shapes. the central most prominent shape, and you'll need to see it from above to notice this, is a cross, okay? And that is the inner wall of the cathedral. And this is what is indicative of most Gothic cathedrals, even Notre Dame, all right? It is actually in the shape of a cross. And so that is the inner wall. Now, the external wall is the walls that kind of hug, all right, that cross, and they line up with the external towers. And so if we look over here on the edge there, the inner wall, which is in the shape of the cross, sits in between the two flanking towers. And then on the external far-facing wall of those flanking towers, you have another wall, all right? And that's the external wall. Now what's interesting, okay, between the internal wall and external walls is that on the inside of cathedrals, they're very, very open. And what that means is, it means that the internal wall doesn't extend as a full solid wall all the way down to the floor. That it's actually divided by arches on the inside, which opens it up. But those arches still support all the weight that we're seeing, because if we look up onto the higher parts of the internal wall that looks like a cross, okay, that's stone there, okay? There's a lot of weight up there, and those arches are all supporting it. But to make those arches stable, okay, that's what the flying buttresses are there for, okay? They're all around. And also the regular buttresses, those are all there to support, okay, the weight, the load weight, and also the redistribution of these weights from all the arches that are everywhere. And so again, look at the shapes. We have a cross, okay? We have square towers, all right? We have archways, we have triangles and squares, and then that's really the whole cathedral. It's deceptively simple, but when you add all these beautiful, okay, spikes, towers, archways, windows, buttresses, and have these simple shapes be placed in repetition to one another, you end up with one of the most beautiful buildings and design styles in the world. It just looks amazing. And so we are in St. Patrick's Cathedral right now, and out of respect for this wonderful building and for those religious practitioners who are currently praying, Sunday services have just finished, I am, of course, being as reverent as possible. Now, what we see here, and this is amazing, is that the entire building is completely open. It's absolutely a feat of engineering genius. So as we go around here, you see these big pillars here and the large pillars there. Well, these are the pillars that are holding up that internal wall. And so if you see us above, we've got the main roof body here, and you'll see those windows from the outside, okay? And so what we have here, we have a line here and a line there of archways and pillars, and they distribute the load from above down onto the supports and into the ground. And so it's hard to even remember that, hang on a second, there was actually a full internal wall. Well, there's two internal walls above us, but they're supported completely. And then when we're here, it's completely open. We have these glorious windows letting in natural light, which just gives this entire building this amazing ambience and feel. So here we can see the internal walls, the pillars holding it up, and the external walls on either side, as I was pointing out before. It is amazing how open this building is on the inside. It's incredible. And it's all open because of archways. Archways everywhere. Okay, and what we see here, I'm going to come up closer because this section here, okay, if you remember the shots from the outside, this cathedral has a massive central tower. Well, right here is where this central tower technically is. And it's like, hang on, where is the tower? Well, it's above us.
is right there. And so these 4 pillars, and look how big these pillars are. 1, 2, 3, and 4. It is these 4 pillars that are holding up that huge central tower. And so all that weight is there. But thanks to the genius design of these arches, all that weight and load is distributed sideways. Now what's interesting, okay, this load, because there's a huge load pressing down at this arch, okay, that load is actually first pushing out sideways, and so the left pillar actually wants to be pushed out leftways, and the right pillar wants to be pushed out rightways. And so there needs to be something on either side of the ends of, so where the pillars are connecting to the arch, okay, that's where the horizontal forces are. And so there needs to be something that holds these pillars and archways in, pushing back, okay, at an equivalent rate to hold that weight in. And if you can push that weight back in, okay, well then it gets directed downwards. The next incredible design feature in Gothic architecture is what we see here. This is what is called a vaulted ceiling, okay? Now, a vaulted ceiling is kind of complex, yet kind of not. It's actually a combination of many arches, okay? So have a look here. Do you see all the arches going one way, going another, crisscrossing over each other? And what that does, if we have a look over here, we can see some of those archways that are part of the vaulted ceilings. So there's a good shot right here, what I'm talking about. You want a vaulted ceiling when you have a huge amount of weight in the roof, because regular supports wouldn't do it. So say if this roof here was built out of stone, okay, if the roof was stone and had a lot more weight above it, this kind of roof would never work. It can support the weight of what it is, but it would not work if it was stone and it had more weight. And so when you have more weight, you need to redirect that load in a more sophisticated manner. And that's what we have here. This is where you get the vaulted ceilings. And they redistribute the weight to, you guessed them, the pillars there and there. So in the shape of the cathedral, if you look above here, that is the center of the cross, okay, of this building, the center. The bottom of the cross extends down that way, and then you have the sides of the cross there and there, okay? And remember, you have the external walls on either side, but the central wall is a cross, and then the top of the cross extends up here. And that is what frames the internal wall structure of the cathedral. But outside of the cross, okay, the external walls is where you have a lot of the pews and the walkways. And at the top of the cathedral, what we have here are individual alcoves. And so if we walk up closer, we will see them. And so these extend again even further out of the outer wall. And what they are individual chapels. And so each alcove is actually an individual chapel. And I believe they are each dedicated to a different saint with these beautiful, I'll just take a look at that, these beautiful stained glass windows. So this is one that's dedicated to Saint Bridget and the Irish Saints Chapel. So, moving along, we will see each individual alcove and each individual chapel going around in a circle.
So there you go. This is St. Patrick's Cathedral in Melbourne, Australia. And thank you for watching, and I hope you have learned a thing or two in classic Gothic style architecture, or at the very least, I hope you've enjoyed. And until next time, never bash your head against a wall without efficient cause, or sufficient cause. Because I'm sure you could do it efficiently, but you'd want a good reason to do it. And a good reason to bash your head against the wall? Do you have any children by chance?